Welcome to another Intermediate Algebra video. In this video, we're going to look at the application side of solving systems of equations with two variables. So our one and only objective, solve problems that can be modeled by a system of two linear equations. In a previous video, we looked at the physical mechanics of how to solve problems that had a system of two linear equations. Here, we're going to look at the application side of it. Remember the three methods we had were graphing, substitution, and elimination. And in this section, in the previous section, it would tell you which one specifically to use. In this section, you're just solving, so you can always pick whichever one you want to. Since graphing isn't one we did a whole lot with or one that we want to focus on too much, I'm going to solve all of them with either substitution or elimination, whichever one feels appropriate for the problem. But it's your call when you do the problems on your own. All right, there are no notes because we did the notes in the previous video. So our first example, these are the application side, so we can expect two linear equations to come from this. A first number is 4 less than a second number. 4 times the first number is 6 more than twice the second number. Find the numbers. So each of these sentences is something we can directly translate to an equation, and then we'll solve. So the only difference here is that now we have to make a translation. So the first sentence says a first number is 4 less than the second number. What does that look like as an equation? What do we want to call a first number? Pick whatever variable you want to. We can say x. Then is, typically is an equals word. That sounds good. 4 less than the second number. What does that look like? The debate is 4 minus y or y minus 4. What do you think? If I say I have 4 less dollars than you have, how do you figure it out? You would take the amount of dollars that you have and subtract 4 from it, right? 4 less than means subtract 4. So it'll be y minus 4. There's the first sentence. The second sentence, 4 times the first number is 6 more than twice the second number. Direct translation, 4 times the first, we've already designated the first number to be called x, so 4x is equals word. 6 more than, what does 6 more than mean? Plus 6. You can put this anywhere. With addition, it doesn't matter which one happened first, but the direct translation says something is being added to 6. 6 more than what? Twice the second number, which would translate to y. We designated the second number to be y. All right, so there are two equations. They're both linear, so this is a system. So ultimately, we're looking for the intersection, right? Graphing, substitution, elimination, you pick. What do you think makes the most sense for this one? In this case, I'm going to choose substitution because x is already solved for in one of the two equations. So let's do this in yellow. This one is already solved, so I'm going to take this and plug it in for x into the other equation. So I'll have 4 times, not x, but y minus 4 is equal to 2y plus 6. So with substitution, we substitute in and then solve for the remaining variable. All right, so we'll distribute the 4. This is all y's at this point. 4y minus 16 equals 2y plus 6. Continue solving, subtract 2y from both sides. If you want a different route at this point, perfectly fine. Then add 16. Let's move that up here. 2y equals 22. Divide by 2, y equals 11. Okay, we found y. What does it ask for? It asks us to find the numbers. So we found one number, we need the other number. How do we find x? Plug it back into any equation along the way that has both of them. Let's use red here. So we have y. I'm going to go back to this first equation because it's pretty clean and nice to plug in 11. We get x is 7. So the answer to the question, find the numbers are 7 and 11. And I listed them in this order because x was designated as the first number. it's not the biggest deal if you were to list this and say 11 and 7. There wasn't any specificity on which one should come first. For some problems, you will have to designate what you're talking about. If it asked for it as an ordered pair, we would write x comma y. It just depends on the question. This one's a direct translation. We don't exactly know what these are representing, but the majority of the rest of the problems will have meaning assigned to the values. So we found the two numbers using the two methods, one of the two main methods we saw in a previous video. All right, next one. The total length of two cruise ships is 27,779 feet. The difference in their lengths is 9 feet. Find the length of each ship. So this one's a little different. We do know what we're talking about, but we're not asked to designate each ship as which one. We're just finding the two lengths. So the first sentence tells us the total length of two cruise ships is 27,779. What does that translate to? Total length typically means addition, and in this case it does. We have a first cruise ship and another cruise ship, x plus y, and their total length is 27,779. The difference in their lengths is 9 feet, so take one, subtract away the other. It's your choice. You could pick x minus y or y minus x, and the difference between them is 9. I promise you get the same answer. I'll explain why later. Then we solve. We've translated, and now we go back to the previous section and say, okay, graphing, substitution, elimination. What makes the most sense? I'm going to pick elimination in this case because I have a positive 1y and a negative 1y. They're already set up nicely, so when I vertically combine, one of them will cancel out. Remember, it needs to line up along the equal sign. X plus x gives us 2x, and 27,779 plus 9 is 27,788. Then we continue solving for x. So divide both sides by 2. We get x equals 13,894, and we're talking about a length of feet. So we can list that here. Then we need the other ship. We have one. So pick either of the two equations. It doesn't make a difference. Just pick one to solve for the other. So I'll go with the first one again. 13,894 plus y equals 27,779. We're solving for y, so subtract 13,894. And we get y equals 13,885. Oh, again, feet, since we're talking about the two ships. Now, if you compare the two numbers, this makes sense for both of them. You don't have to actually do the addition, but if you add the two together, you can expect it to be about 27,779. It is that. And the difference is 9 feet. So the difference, if we subtracted one from the other, there's about a 9 difference there. And there should be. So this is good. Now, you might be asked to just present the two answers like this. You might also be asked to present them like this. Maybe it says the longer ship, and then you'll put your answer, and the shorter ship. Now, when you set up the problem, it didn't really matter in this case how you set it up. You just had to set it up and go. But now, if you're answering, if this was how you had to answer, and you're supposed to type in something into each box, where does each one go? Well, which one's the longer ship? They both 13,894 must be the longer. So you can write that there. And the shorter ship, 13,885. So you can fill them in like that. It might be the case that it just says type them in, but it might set them up the longer and the shorter. So keep that in mind. All right, let's see another one. In a particular year, a total of 41,678 students studied abroad in 2 of the most popular host countries. If 8,420 more students studied in the most popular country than in the second most popular country, find how many students studied abroad in each country. Okay, so in this case, we have to first identify what are the things we're looking for. There's a system of 2 equations, and the 2 equations will have 2 variables, So what do we want to designate X to be? What do we want to designate Y to be? What are we talking about here? We're talking about students that studied abroad in 2 different countries. In the most popular, so let's say this is the students in most popular country. And then that would make Y the number of students in the second most popular country. When they're very distinctly different, like these two, like this problem, it's really helpful to identify right off the bat, what are the 2 things I'm looking for? That's what I'm trying to answer. So now let's use the information we have in the problem to try and translate into equations. In a particular year, a total of 41,678 students studied abroad in the 2 most popular countries. So how can we translate that? A total of them means addition. There were this many students in the most popular and this many students in the second most popular for a total of 41,678. Okay, then 8,420 more students studied in the most popular country than in the second most popular country. How do we translate that? There were 8,420 more students in the most popular country. So the most popular country consisted of students in the second most plus 8,420. Now, if you set it up with the variables the opposite way, when you got down to the end, you would just see that your numbers were opposite, which is okay as long as you identify that for yourself. Okay, so we have translated to equations. Now we go into solving mode. Which method do we want to use here? I think substitution looks the best here because we already have X solved for. So we'll plug that in. Y plus 8,420 plus Y equals 41,678. Then continue solving. 2Y plus 8,420, 41,678. Subtract 8,420. 2Y equals 33,258 divided by 2. $16,629. And what does this answer mean? It means there were 16,629 students that studied abroad in the second most popular country. We don't know what these countries are, and that's okay. The data is just about the most popular and second most popular. But we were asked to find how many students studied abroad in each country. So we go back and solve for X. You can use whichever equation you want to. I'll go with this one. When we solve this, all we have to do is add them together. We get 25,049. And we've already labeled that X means students in the most popular country. If we had not made those labels, imagine that we hadn't listed what the variables represented, then you would need to say students in most popular country. And for the other one, students in second most popular country. Since we labeled at the very beginning what the variables represented, it's not necessary to write these descriptions with the answers, but without those initial labels, you would need to write that there. And again, if at this point, in the very beginning, you had flip-flopped X and Y here, when you got to the end here, you would see that the Y value was larger, and you would just have to recognize, oh, that must be the most popular country then. Maybe I mislabeled, and then go back and fix it. It's possible to happen, but I wouldn't expect it in general. All right. One more together, and then some practice problems. At a theme park, 2 boxes of popcorn and 4 ice cream bars cost $24. Separate scenario, 5 boxes of popcorn and 3 ice cream bars cost $33.75. Find the cost of 1 box of popcorn and of 1 ice cream bar. So what are the things we're actually looking to solve here? It's listed pretty clearly in the last sentence here. We want the cost of 1 box of popcorn, so we'll call X popcorn, and Y ice cream bar. And it's the cost, so put a $sign there. Okay, so let's use each set of information to figure this out. The first sentence says, or the first scenario, 2 boxes of popcorn and 4 ice cream bars cost $24. So how do you set that up? 2 boxes of popcorn, what does that look like? We don't know what a box of popcorn costs, but if we did know, if we knew that it was $10, and I said, go buy me 2 boxes of popcorn, how much money are you going to need? 2 times 10. So you have to multiply. 2 times whatever the cost of popcorn is, which is what we don't know. If I also told you to buy me ice cream and we knew that cost, you would add the cost together of 4 individual ice cream bars. And the total cost of these things is $24. So there's the first translation. The second, 5 boxes of popcorn and 3 ice cream bars cost $33.75. So 5 boxes of popcorn, 5 times the cost of popcorn, plus 3 times the cost of ice cream, because we're buying 3 of them, is equal to $33.75. Okay, we have translated. We know what our variables are. At this point, we switch into solving mode. Choose a method and stick with it. I'm going to go with elimination in this case. And the choice is yours, whatever variable you wanted to get rid of. I'm going to choose to eliminate x. So I'm going to make the coefficient on the x 10 and negative 10. It's the smallest number I could change them to. You could go bigger, but 10 is going to be the nicest. So if I want them to be 10 and negative 10, what do I have to multiply the first equation by to get a 10 to be there? You need a 5, which gives me 10x plus 20y equals 120. You can use the calculator. And then the second one, I need it to be negative 10. Remember, we need 1 positive, 1 negative, the same coefficient, so they'll cancel out. So I'll multiply in a negative 2. Gives me negative 10x minus 6y equals 33.75 times 2. Times negative 2, negative 67.5. Okay, now it's set up. Now actually eliminate. X is canceled. 20 minus 6 is 14y equals 120 minus 67.5 is 52.5. Then divide both sides by 14. We get y equals 375. Is this reasonable as an answer? What does y represent? The cost of ice cream. Is that possible? Yeah, decimals aren't always great, but when we're talking about money and it comes out to 375, definitely reasonable and possible. Okay, so we want both. We have y. Let's also find x, our cost of popcorn. So go back and plug in anywhere along the way. I'll just go with the first one. 2x plus 4 times 375 equals 24. So this is what we're solving. 4 times 375 is 15. 24 minus 15 is 9. Divide by 2, x equals 0.5, but we're talking about money, so 450. So the cost here was 450 and ice cream, 375. Now, if you have already identified what x and y are, then you don't have to label them. If not, you can write ice cream and $sign popcorn, and that'll clear things up. Okay, So these are 4 practice problems, each somewhat similar to the 4 that we just did. Go ahead and take a couple minutes, however long you need, to pause the video and go through these 4, and then we will go through them one at a time together. Okay, you're back from your long set of practice. Let's see what we got. The first one, twice one number plus a second number is 42, and the first number minus the second is -6. Find the numbers. Translation, first sentence, twice one number, 2 times x, we'll call this x, and the second number, y, plus a second number is 42. And different scenario, the first number minus the second number is -6. Find the numbers. This one sets itself up for elimination. The y's already have the same coefficient, opposite signs. So we eliminate y, combine x, and 42 minus 6 gives us 36. Continue solving. We get x equals 12. There's one number. Find the other one. 12 minus y equals -6. Solve this. We get y equals 18. So the two numbers are 12 and 18. Did you get that? If not, pause, check your other work. We'll still keep going through. Okay, the second one. Karen bought some large frames for $15 each and some small frames for $8 each at a closeout sale. If Karen bought 22 frames for $239, find how many of each type she bought. So what are the two things we're talking about? We can say X can be large frames and Y can be small frames. Some of them were $15, some $8. She bought 22 total for $239. So she bought some large frames and some small frames, total of 22. And some of those frames, the large frames, were $15 each. The small frames were $8 each for a total of $239. So here are your two equations. Then pick your method of solving. I'm going to go with elimination in this case, and I'll choose y to get rid of. So I'm going to multiply the first equation by 8 and the second equation by -1, which gives 8x plus 8y equals 176. Second equation, -15x minus 8y equals -239. Vertically combine the two together. 8x minus 15x is -7x. The y's are gone, and we get -63. Continue solving. Divide by -7. We get x equals 9. And what does this mean? She bought 9 large frames. Okay, how about small frames? Go back anywhere along the way that has both. I'll pick this one, nice and easy. And we get 13. So we've already labeled, so if you did that, you don't have to list here. If not, you'd have to say 9 large frames and 13 small frames. 2 down, 2 to go. How are we doing so far? Let's see how the rest go. All right, next one. The total length of 2 dogs is 58 inches. If one dog is 18 inches shorter than the other, find the length of the 2 dogs. So here we're just looking for 2 lengths, no distinction on one or the other. So let's use the information to build equations. The total length of 2 dogs is 58 inches. So a first dog and a second dog together, 58 inches. If one dog is 18 inches shorter, 18 inches shorter means something minus 18 than the other, find the length of the 2 dogs. One dog minus 18 gives you the other dog. Okay, so here's our equations. I'm going to use substitution in this one because it's already solved for x. It's always up to you. which gives us x. Ooh, whoops, arrow here, not there. Oof, take that out. Okay, so we have y minus 18 plus y equals 58. We substituted y minus 18 in for x into the first equation. Then combine 2y minus 18 equals 58. Add 18. We get 76. Divide by 2. We get y equals 38. So one of the dogs is 38 inches in length. The other dog, y minus 18 equals x, is 18 inches shorter, which gives us 20 inches. So the length of the two dogs, 20 inches and 38 inches. It didn't give a distinction. Again, you might see it ask you to present your answers like this: the longer dog and the shorter dog. If that's the case, once you get to this point, you'll just fill in the appropriate numbers. This would be 38 inches and this would be 20 inches. All right, one more. A total of 78 seats for a concert are sold, producing a revenue of $483. If seats with a cushion cost $10.50 and seats without a cushion cost $2.50, how many of each type of seat were sold? So this time it is distinct what we're talking about. We're looking at the $10.50 cushion seats. We want the number of them and the number of $2.50 without cushion seats. So it's number of seats, cushion or not cushion. So let's use the information to translate. A total of 78 seats were sold. So set it up this way. Producing a revenue of $483. We know individual costs, so we can set it up the same way, sort of like the second one, but now we know the cost. The cost times the number of seats plus cost times number of seats gives you the total revenue. So we have 10.5 times the number of cushion seats plus 2.5 times the number of without cushion seats, giving you a total of $483. So the first equation is only about number of seats. The second one includes all the dollar amounts added in. Now, your choice which method. This one's probably set up more nicely for elimination, but I don't really want to multiply in decimals. So I'm going to go with substitution, and I'm going to solve this equation for x. Just subtract y over. We'll have 78 minus y. And then substitute that in. So we'll take 78 minus y and substitute that in for x, which gives us 10.5 times 78 minus y plus 2.5y equals 483. All right, continue solving. Distribute the 10.5. That gives us 819 minus 10.5y plus 2.5y, 483. Combine like terms. The negative 10.5 plus 2.5 gives us negative 8y. If we bring over that 819, we get negative 336. Divide both sides by negative 8. Y equals 42. So there were 42 seats sold that did not have a cushion. Again, we've labeled, so you don't have to do it again. If not, you write the label. Okay, so we're still looking for the number of $10.50 cushion seats that were sold. So go back, plug in anywhere along the way. I'll go with this one. There were 78 seats sold total, so 78 minus 42 gives us 36. Whoops, got a little erase there. 36. So 36 seats with cushions, 42 seats without cushions sold for the concert. Total of 78, total revenue of 483. All right, so in this video, we looked at the application side of solving problems that had two linear equations, each having two variables. Looks like we've finished everything. I will see you soon for more information.